So we've learned that as far as roots of polynomials go, we know exactly how many roots any polynomial will have by looking at its degree. The question is, how do we find them? All right, so the procedure that we're going to use is we're going to first start by looking for the easiest ones to find, and those are the rational roots. Remember, these roots can be rational, irrational, or even complex. So the ones we're going to start with rational roots. Now, that's the procedure. We're going to find rational roots and then figure out if there might be irrational ones or even complex ones after that. Now, not every polynomial has a rational root, but we're going to start here with ones that do. So how do we do this? Well, first, as we look for these rational roots, we have to think about what the possible rational roots are. So this is good news, because obviously if we just say looking for rational roots, there are infinitely many of them. So we do have a place to start. We can identify the possible rational roots. So what we do is we look at two numbers in the polynomial, the coefficient of the leading term and the constant coefficient. And what we're going to do is we're going to make our possible rational roots out of factors of those numbers. So basically we know that the possible rational roots are of the form r over s, where r represents a factor of a sub 0, the constant, and s represents a factor of an, the coefficient of the leading term. So that means we're going to take the factors here of a0 and we're going to put them over all the factors of an, and we'll be able to put together a list of the possible rational roots. Let's see this. Okay, so here we have 2x cubed plus x squared minus 13x plus 6. So we're going to identify the 2 and the 6 here. So what we need the factors of 6 and the factors of 2. So the integer factors of 6, well, how do you get 6? Well, 1 times 6 and 2 times 3, but we could also have -1 and -6 and -2 and -3. So we're taking all the positive and negatives, all the integer factors. So we would say plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So those are all the integer factors of 6. What about 2? Well, 2 just has 1 and 2, so in other words, plus or minus 1 and plus or minus 2. So now we have to figure out the possible rational roots. Well, it's going to be a lot of combinations, because basically we have to take every one of the factors of 6 and put it over every one of the factors of 2. Again, note, it's the factors of this number over this number. So the last number over the first number as coefficients. All right, so that means I'm going to have to take plus or minus 1 from the 6 and put it over plus or minus 1 from the 2's. Plus or minus 2 over plus or minus 1, plus or minus 3 over plus or minus 1, plus or minus 6 over plus or minus 1. So that was taking each one of these and putting it over plus or minus 1. And so now I have to do the same thing over plus or minus 2. So plus or minus 1 over plus or minus 2, plus or minus 2 over plus or minus 2, and plus or minus 3 over plus or minus 2, and plus or minus 6 over plus or minus 2. That's all the possible rational roots. So that's a lot of them, but there's a lot of duplicates in there. Because if I just look at the first, look at plus or minus 1 over plus or minus 1, that can only actually come out to be two numbers. Either that comes out to be 1 or minus 1. So, but plus 1 over minus 1 and minus 1 over plus 1 both give us the same values. There's a lot of duplicates. So removing duplicates, let's see what we get. So plus or minus 1 over plus or minus 1 will only give us plus or minus 1. Plus or minus 2 over plus or minus 1 will only give us plus or minus 2. And plus or minus 3 over plus or minus 1, plus or minus 3. And similarly for the 6, plus or minus 6. Plus or minus 1 over plus or minus 2 would only give us plus or minus a half. Plus or minus 2 over plus or minus 2 is just going to give us 1 or negative 1. We already have that. Plus or minus 3 halves is what we'll get out of the 3 over the 2. And plus or minus 6 over plus or minus 2 is plus or minus 3, but we already have that as well. So we end up with these 1, 2, 3, 4, 5, 6, so 12 numbers, 12 possible rational roots. That's pretty good, considering that we started with all possible rational numbers, all rational numbers as possibilities before this. So how do we limit it down? Well, now what we're going to have to do is we're going to have to try some, okay? So I want to know, let's start with plus 1. So I'm going to try plus 1. So how would I try plus 1 to know whether it's a root? Well, remember, a root of a polynomial would mean x minus that number is a factor, and it would mean that that number plugged into the function would give 0. So I could just do f of 1, which would be 2 times 1 cubed plus 1 squared, minus 13 times 1 plus 6. And if I do that, so that's 2 plus 1 minus 13 plus 6, that's minus 4. So the remainder being minus 4 tells me it's not a root. I'm looking for a remainder of 0. So then I could go to the next one. I could try negative 1, say. Now you really don't have to do this in any specific order. I just like to go along the list. So 2 times negative 1 cubed plus negative 1 squared minus 13 times negative 1 plus 6 is 18, if you figure that out. So that's not a root. So negative 1's not a root. Let's try 2. F of 2 is 2 times 2 cubed plus 2 squared minus 13 times 2 plus 6. All right. So that would be 16 plus 4 minus 26 plus 6. That gives us 0. Ah, good. We found a root. So what does this mean? We found that if we put 2 in, we get a root. Well, I'm sorry, we get a remainder of 0. Therefore, we know 2 things. X equals 2 is a root, and x minus 2 is a factor. So that's great. We found that 2 is a root. So what can we do from there? Well, if we know that 2 is a root and therefore x minus 2 is a factor, we could divide. So let's do this division. All right, x minus 2 into this polynomial. All right, so x minus 2 into 2x cubed plus x squared. So x to 2x cubed, I'd need a 2x squared. Multiply that, I get 2x cubed minus 4x squared. Subtract. That'll give me 5x squared. Bring down the minus 13x. Then do x minus 2 into that. That's going to give me a plus 5x. Multiply that out. That gives me 5x squared minus 10x. Subtract. And this will give me a minus 3x. Bring down the plus 6. Do it again. I need a minus 3, giving me minus 3x plus 6. I subtract and I get 0. Now that's not a surprise. I knew I had to get 0 because I knew I was supposed to get a remainder of 0 if x minus 2 divides into that. So what did we find? We found that the f of x, the original f of x, 2x cubed plus x squared minus 13x plus 6 is actually x minus 2 times 2x squared plus 5x minus 3. Okay. But that is just a quadratic there. We could factor that. X minus 2. And then that is this part here is going to factor into 2x minus 1, x plus 3. All right, at this point, then we really have it, because we know this one is going to give us the root of x equals 2. And when is 2x minus 1 equal to 0? For x equals 1/2. And this one would give us x equals minus 3. There we have it. We just found all our roots. 2, 1/2, and minus 3. Now they all happen to be rational roots here. They didn't have to be, but they all were. And notice they're actually all, so we said 2, 1/2, and minus 3. 2 is in there, 1/2 is in there, and minus 3 is in here. So they all did come from our original list of possible rational roots. And again, they didn't all have to be rational, but if they are all rational, they better all have come from that list. Okay, so we could have started with any one of these, done the whole procedure, and gotten the other two. It really wouldn't have mattered. So that's how we found the roots.